Welcome to video notes for lesson 1.2, powers and exponents. Today your learning target is to evaluate and write numerical expressions involving, which means using, involving exponents. And we'll just be using whole number exponents today. So when we look down, the next part of your notes here is a power is. And a power is a product of repeated factors. Make sure that's an F. A power is a product of repeated factors. Make sure you write this in your notes. The next part is the base of the power is the repeated factor. The repeated factor. And the next part is the exponent of a power indicates the number of times the base is used as a factor. So the number of times the base is used as a factor. So let's take a look here at number 3, which says underline the base. And we're going to do that with red. And we see that 3 is our base. And if you look at this, I actually like to do this so that way I can remember this a little more visually. I'm going to draw a line from 3 to right here because that shows me what that base means, the repeated factor. Now, the next part is put a box around the exponent. 4 is my exponent. 4 is my exponent, which is the number of times the base is used as a factor. Okay, make that into an R a little bit better. So, let's do a couple of examples here. Go down to number 4 here. Copy example 1 from page 12 in your textbook, which is 4 times 4 times 4 times 4 times 4 times 4. 4 times 4, 5 times. So, you might think this means 4 times 5, but no, what actually it means is you're going to take 4 times 4 and 4 times 4, which we know is 16, and 16 times 4. What does that equal? Well, we'll figure that out later, but the important thing to remember right now is that it's going to be 4, because we're writing this as a power, a product as a power. So we have 4 to the 5th power. 4 to the 5th power. Let's do another one here. Let's take a look at example B from the same page, which is 12 times 12 times 12. So, what is our base? Our base is 12 because it's our repeated factor here, right? How many times we're using this 12? 3 times. Okay, so that's our power. So, 12 to the 3rd power is the answer here. Now, if we take a look at number 5, where it says copy example 2, finding the values of powers. Now, this is something that will be a little more difficult for us, and there will be a time for you to use a calculator when we're doing this, and we'll also talk about how to do that using your multiplication chart. So let's take a look here at the bottom of page 12 for example 2. It is 7 to the 2nd power. What does that mean? It does not mean I'm going to put a little box here. Does not mean 7 times 2. Does not mean that. Nope. It means 7 times 7, which we know equals 49. That's a relatively easy one because we can use our multiplication chart or our rote memory of recalling what does 7 times 7 mean. A little more challenging one would be 5 to the third power. Again, it does not mean 5 times 3. Does not mean that. No, that's bad. What it means is 5 times 5 times 5. And we know that 5 times 5 is 25, and 25 times 5 equals 125. So that is our final answer. Okay, again, it does not mean 5 times 3. Rather, it means 5 times 5, 25 equals 25 times 5. Okay, so this is why we're going to be using our calculator, because it's going to be some longer math problems than we are probably used to doing in our head or on a piece of paper. So, okay, so now let's take a look at number 6, copy example 3, identifying perfect squares from page 13. Now, by perfect squares, a great example of working through this is to draw our square. Okay, and we're going to put 64 right in the middle. And we're trying to identify if there are two numbers that we multiply together that equal 64. Now, one way of doing this is you can look through and use your multiplication chart. You can look at what two numbers do you have there. Well, if we check it out, we have 8 and 8. And since they are the same, we know that 64 is, yes, a perfect square. Okay. Another example of a perfect square, like if we were to take 1 and trying to figure out, is 1 perfect square? Well, 1 times 1 equals 1. So, yes, 1 is also a perfect square. Let's take a look here at 20. 20 in there. Now let's look at the two numbers that we know that multiply together to make 20. The factors of 20. What are they? Well, we have 5 and 4. That equals 20. We have 10 and 2. I'm going to put commas here so that we know that they're a different set. We even have 20 and 1. But we also can see right here that none of these numbers, they don't match. They don't match at all. So 20 is not a perfect square. No, it's not. Now, if you take a look at, well, let's be on the next page. On the next page, you're going to have some practice problems for you to solve on your own. And if you have any questions, you can ask me for help. So if you take a look here at 3, you can see that it's finding the value of the power. So that's where you're going to be using a calculator or your multiplication chart to find out what the value is. Same with 4 and 5 and 6. And then with 7, 8, 9, and 10, again, make sure you do the whole, make a square, put it in the side, and see if you can come up with two numbers that are the same when you multiply them. So, then on the bottom, you've got on your own, write the product as a power, and then find the value over here of what is 4 to the third power. Again, if you have any questions, please raise your hand and I will come around to help you.